Good afternoon, Europe. Good evening, Asia. Good morning, Americas. It's a great pleasure for me to be again with you in another Cappuccino Talk. And particularly, I am super excited to have this cappuccino and share the highlights of the 4 finalists of the Lean Diamonds Awards for the Lean Innovation category. So in the previous cappuccino, we had the Lean category. Today, we'll have the Lean Innovation category. So what are these cappuccino talks? So for those that are new, my name is Dr. Mirna Flores. I am the co-founder and president of the Lean Analytics Association. It's a nonprofit association based in Switzerland, and we have 10 years already. And this cappuccino started a couple of years ago to share lessons learned, experiences, nice case studies, best practices from practitioners, academics, and people that are working and are passionate on the topics of lean innovation and digital transformation. So you can interact with us. We have a chat box. We have a Q&A button. So don't hesitate to ask questions to all these gentlemen that we have today, and also to Maria Elena, who is also part of LAA participating to this cappuccino talk. So I invite you all to grab your coffee, water, cappuccino, juice, anything that could be nice and comfortable for you, and enjoy. As I was saying, we are a spin-off organization, a non-profit organization from EPFL. It's the result of a European project that actually Dr. Ahmed Al-Ashab was leading, that was called Lean Product and Process Development with different organizations. And since then, when it was established in 2012, we have been documenting different cases, publishing a couple of books, and we proposed this award together with PricewaterhouseCoopers and Cranfield to really acknowledge all those practitioners, all those people, could be also public organizations and private and everyone, who are working hard and who have implemented good practices to improve processes, to innovate, to engage employees for problem solving, to create this culture of continuous improvement. So we have 10 finalists at the end of the day. We have these 10 finalists. And I'm super happy to share, we'll have the award ceremony on the 8th of June in Brussels, in PricewaterhouseCoopers. It looks like this. The building, they are just inaugurating a new building this year. And the big surprise is the registration process is open. So if you go to this link, I kindly ask Marilena to please place the link or copy paste the link in the chat box. In this link, you can register both on site and online. The event is free, does not have any cost, any price. So we'll have around 100, 150 people attending this event to listen to all these 10 amazing stories from the finalists. Another piece of news, yesterday we launched this Lean Trends Survey. It will be open until the 10th of May. And here we have identified very, very key 10 questions to understand some key trends about the topics, lean innovation and digital. And we will present the results of this survey also in the awards. So this is the framework that we use to document all the cases in our research. It consists of 4 building blocks: strategy and performance, skilled people and collaboration, efficient processes, and continuous improvement, and change. So these building blocks and these enablers are what we document in the cases that we publish, and we work collaboratively with all these organizations. So today, I'm happy we're going to talk about the innovation process. And just to be to align on some key concepts, innovation refers to building something new, creating something new, and being successfully launching that in the market, or improving something that is also giving competitive advantage. So really changing the way we work, changing processes, improving products, services, and so on. And we have as input many potential elements like needs from the customers, market needs, what our competitors are doing, and so on and so forth. The particularity of this process is not straightforward. It's not a linear process. It requires iterations. It requires investment. It requires a lot of new discoveries and training and learning cycles to learn, because at the end of the day, we will be creating new knowledge when we create something new. And Another key element and practice is don't expect to be right the first time. On the contrary, this process requires, as I was saying, iterations and learning cycles to reflect and fail sometimes and see these failures as part of the process itself. So having said that, and having shown the key concept behind innovation and the fact that lean practices could also be implemented in this process, which most of the times is intangible because we are transforming knowledge into something new. It's a pleasure for me to introduce the 4 speakers. We will start with Dr. Ahmed Alasha. He is a reader in Cranfield University, of course, passionate about lean innovation, lean transformation, everything. And he has been working with different organizations in UK. He will be presenting today the case from Rolls-Royce Aerospace. Welcome, Ahmed.
Carmena Flores, just let me put it in the first slide. Yes, you see it well?
Yes, thank you, Ahmed.
Right, okay. So I'm not going to introduce myself. I think Benna did that. We've been working with so many different companies, actually 3 of the company presenting today that is based on the work with us. And unfortunately, John Parson cannot make it today, so asked me to present the work we did with them. So this is the journey. They started really considering the application of lean thinking in product design, and that's what they call it, lean product excellence. And then they collaborate with us writing the proposals. I could see Paul Ewers as well in Visteon in the attending this. So we had Visteon, Rolls-Royce, Volkswagen, CTEC, and Indiset. So we put the proposal to European Commission in 2007, and then we managed to get the money. Was 7.6 million, and was the kickoff in 2009 at Cranfield University in the United Kingdom. And the consideration was to transfer one of their product development process model called SDI, System Design and Integration, into a lean, and that was based into a helicopter engine, which is I'm going to show part of it. And then we did other transformation. The work really with them was from 2007 until 2015 plus. And then we managed, after the lean PPT, we managed to get another 3.5 million UK pound project from British government, and that was another 2 years basically. Then the case study was about low noise engine, and then the work we did in transforming the different application or the different stages of their product development ended into sort of like a set-based design navigator project, which is actually the researcher was an MSc by research under my supervision, and they won several innovation awards within the company, and they developed eventually what they call data labs, and John Parson and his team considering using digital twin to support product design and development. So one of the things we did with all the companies we work with them, and you're going to see it maybe with other presentation, is we developed the performance measurement, and we measure how their current practices against the good practice. And in the case, of course, Rolls-Royce is a very big, so I'm talking about a certain business unit. As you can see, it was 2.5 from basically from 0 to 5, and 2.7 is the as is practice, and they want to be into 2.4. So that was the application of the aim of the project is to transform the current product development process of Rolls-Royce using set-based concurrent engineering principles. In addition, as we are doing the transformation, we want to prove if this will working or not. Actually, as we are talking, we're just finishing project with Atlas Copco about something very similar to this, also involving some digital twin application. So that maybe, Mirna, we consider it for the future talk, cappuccino talk. Anyway, so the idea is to test this process model in using a real case study. The idea is they have the commercial project, and parallel to it, we were doing the implementation of the case study. So all the work published in a journal paper back in 2013, and those who are interested. I don't know if maybe I'm going to share some of the slides with the participant, but all the details in these papers. Well, not all the details, I'm sorry, part of the detail, because we had so many different words. So this is what they call SDI, System Design Integration, sort of like the V model. And what they have it the system level, subsystem level, and the component level. So they have what they call it System Design Review 0, System Design Review 1, System Design Review 3, System Design Review 5, and so on and so forth. And then have the subsystem, component, and subsystem and the component level. So as you can see here, although they are showing you what the review, but doesn't tell you what exactly the activity that you need to use and the exact tool you need to use. So that was the transformation. This is the engine. Of course, this is sort of like architecture. And Rolls-Royce, you have a lot of their tool and method developed internally or modified. So this is basically functional modeling to see for the any engine what you need to take the air, clean the air, compress the air, and the compressed air is what you're going to do is you put it in the combustion engine when you have the fuel and the ignition, and you get the power that will generate the required torque and release the gas. This is like the very top level. The emphasis in the work is about defining the functions of the system and the subsystem. Then the designer and engineer come up with the solution to represent these functions. So what we did, I'm going to show you, because of the time limitations, I'm going to show a very small part of it. So we took their product development against the principle of set-based design, mapped them, and we created the new model. As you can see, the new model has got two colors. The blue one is what the activity they do, and the green one, as we brought them part of the principle of set-based concurrent engineering or set-based design. So these are as you can see, what I'm showing you here on the right side are the principle. So we converted into this, for example, map design space. As you can see, there is a range of activities here. Remember the green one, what we brought to them, and what the blue one is what they do actually and supporting this activity, and so on in each of those different stages and activity. And the idea is basically this one, the end of it is basically the report has got the data of those different activity, which will be reviewed in this, as I told you, system design review and so on. So this is representing system design review 1. So one of the things is basically I'm showing you here the activity that we implemented. So F4, as you can see here, F4 desired level of elevation, and so a different slide would tell you the different activity within this model. So we have level of innovation, and you can see here we have the color one is they do with the company and they got level of innovation. The gray one, they do not have level of innovation. That means they use the same solution of previous project or the work done by another company. So they have the intake, combustion chamber, and turbines that got different level of innovation, as you can see them here. So the intake has got research and development. That means there's quite a lot of opportunity innovation. Combustion chamber has got high level, and the turbine has got medium level of operation. So what we did, we went to the design space. We populated, as you can see, these are different images to represent, but the reality, these actual design. Remember, this is conceptual design. The idea to explore as possible. So there is a sketching, there is some description from previous project, there's very, very top level conceptual design, and so on and so forth. So what you see here, these come from the functional modeling. If you remember, the intake, the clean the air, compress it, and so on and so forth. And they come up with combinations. So if you say 6 times 5 times 2 times 3 times 1 times 5 times 3, you will get 2,700 possible combinations for this. So what we do, this is virtually impossible. Actually, when we work with them, they told us some not nice word, to be honest with you, because they say, you know, having one engine costs them that much, take that long. So how are we talking about possible of 2,700? We prove them wrong quickly, because what we do, we aggressively narrow down, and that is what set-based concrete engineering, set-based design, narrow down aggressively the number of possible solutions. So we put criteria of the impact on key value attributes, the knowledge and experience, and the technology readiness level. These number are the solutions. So here we have 6. Yeah, this is come from here. You see, we have 6, then 5, and 2. So these are the solutions. And then when we put the criteria, we kept the good ones and eliminated the one that is not suitable for this project. So we reduce it significantly from 2,700 to 16. Then we add another criteria about the integration, and we reduce it from 16 to 6. So these are the final 6 possible consideration, and we evaluated from 1, 3 to 9 in order to see how they address the key value attributed in this specific project was the cost, fuel consumption, service, and weight. And you can see configuration 1 was the good one. So we go to the basically the visual representation of the final design. And basically the summary is we explore the value of solution 2,700, reduce it to 16, to the 6, to the final solution. And thanks to the application of set-based concrete engineering product developer. So this is what I have, and the impact of that, you could see that is that their product development has been improved significantly. A linear process has been achieved in order to reduce the time to the market. And then the optimal solution, and that's very important. You see, as you know, all the company, they have process product development, but they always come with that suboptimal solution. Within the application of what I show you, then we could achieve a high quality and optimize the solution. Thank you very much, Myrna, and I pass it to the next presenter.
Thank you, Ahmed. That was very, very interesting. So our second finalist of the Lean Innovation category is Atlas Copco. So it's a pleasure for me to introduce Ben Taylor. Welcome, Ben.
Thank you. 1 second, I'll just share the screen. Okay, is that sharing okay?
Yes, perfect. Thank you.
Yeah, good. Okay. So yeah, thanks for joining me today. Thanks, Myrna. So I'll take you through our agenda today. So I'll run through the introduction, and then we'll go through our lean journey at Atlas Copco. I'll run through how we applied our set-based concurrent engineering project, and then I'll talk about the impact across the business. So yeah, a quick background about Atlas Copco. We're a market leader and the inventor of self-pierce riveting, SPR. Now they're only little rivets, but there's about 3,000 of them per car, and they're integral to the structure of the car body. We provide all the joining system from the bulk feeders, which feed rivets to the end of the robot effector, which are then inserted into the car body through the setting device. We've been in the market since 1980, and yeah, that's a bit of a background about Atlas Copco. So our lean journey, in 2018, we began our agile principles integration. So we started looking at Scrum processes within the software development team and implementation of those. And we actually found that there was a big improvement across the department by running those agile processes. In 2019, we decided to expand those through digital tools across the rest of the department. And then in 2020, obviously the pandemic hit. We decided that it was time to really start accelerating new processes and looking towards lean PPD as well as agile, and trying to bring that into Atlas Copco. We needed obviously to start looking at new processes. The market was getting tough and things were starting to change. So we looked at bringing those in. And our global R&D manager actually attended a course at Cranfield where he learned about lean PPD and brought those processes back In 2021, we initiated an SBCE, a set-based concurrent engineering pilot project with Cranfield University. That was under Dr. Ahmed, actually. And that project was a good success, and I'll run through that with you now. So strategy and performance. Initially, we took an analysis of, and you can see on the radar charts on the left there, we looked at the where we were essentially in terms of lean PPE processes. And as Ahmed alluded to earlier, we went through that process, and we established that we were at 3.3 initially. So with some improvement and looking at where we wanted to be in the next sort of 12 months, we worked out that we want to be about 3.9. So the key drivers of those were we wanted to maintain our position, obviously leading the market. We wanted to attract and retain the best talent and also develop world-class engineering. So we took the process from Cranfield. We went through all the different lean issues there, and then that's where we came up to in the end. So our project. So the collaborative project with Cranfield started off with a design sprint, as we like to call it. So essentially, we during this design sprint phase, we identified all the customer drivers, the key customer requirements, the key design parameters, and eventually created a specification. The product chosen was a quick connect T-tube device. So essentially, what this does, it connects two T-tubes together quickly and efficiently in the field, and the T-tubes feed rivets to the end effector gun, and obviously set them in the car. So it's a really critical part of the system, this. The customers wanted something quick release so they could replace T-tubes more quickly, and obviously reduce maintenance times. The reliability was a real key driver of this one. There is no redundancy on the system, so we needed to make sure that was reflected when we passed the information over in the collaborative effort. So we worked with Cranfield on that. We came up with these parameters, so criteria, sorry. So cost, design performance, reliability, manufacturability, and installation were sort of chosen as the main criteria. And then of those, we drilled down and selected three main sort of criteria, which was the reliability, which came out on top, design performance second, and the installation speed third. So from those, then we went on to looking at the designs which had been created collaboratively between both us and Cranfield, and we initially had 20 designs, which was good starting block, and we started to feed those through the system and work through the set-based concurrent engineering process. So you can see here we started with the 20, the initial designs, and then the application of the lean. As it went through the process, we eventually got to our final solution, which was the favoured solution against those initial criteria. Against our the product we had in the field at the time, the process actually led to something that was 18% lower mass, reduced the part count to 1 from 3. It eliminated a complex installation, reduced the connection time by 92%, and also reduced the cost by 20%. So it was a really successful process when we ran through it. So continuous improvement. We've started to introduce digital lean across the business. This is in the form of tools, things such as Workfront, which allow us to look at burn down charts. And this also aids transparency across the business and brings everybody together really to working on the same sort of thing, the common goal essentially, which is really good in terms of efficiency processes. And we've also introduced Miro boards, which are digital whiteboards. And obviously in this time of the pandemic, it's been great for people from working from home, but it also allows us to collaborate with our friends all over the globe, which is fantastic. We formed agile teams to conduct continuous improvement activities. So as well as the core sort of teams that are working on development processes, we've also got teams that are looking at agile processes and improving on those. Industry 4, we started looking at the latest trends there in terms of we now have an application on your smartphone which people can use to essentially look at installation instructions for tools by the use of QR codes and those sorts of things. And we've also recently started commissioning a digital twin, which will allow us to begin analysing the system in a digital sense. And again, if the efficiency savings there will be great. So the impact across the business really, it's had a significant impact on delivery, cycle time and time to market for our products. It's reduced product development cost. Return on investment has increased, sorry, so we're seeing a lot more for our money once the project's underway. And also the R&D allocation, although there has been a criticism that there's more of an upfront cost with an SBC process, we're seeing that the benefits once we're into the feasibility stage of a project really outweigh those initial costs, and there's a huge improvement there. And yeah, we've seen a vested interest as well from basically all team members, which is great. So everybody's got really good visibility of where we're working and how the process has been applied. So to summarise, yeah, the use of SBC within product development has measurably enhanced what we've seen. It's really reduced time to market and improved the number of concepts that we're coming up with, which is great. It's improved our collaboration with external partners, which is of mutual benefit, especially with Cranfield University. Their students get exposure to our work-based environment and industrial environment, and we also gain from the likes of Ahmed Al-Sharb, who has fantastic academic qualifications. And then last but not least, we've worked out that failing fast and hard is preferable to failing later and much harder. And that's it. Thank you.
Thank you, Ben. Really, really great presentation. Well done. Thank you.
Thank you.
It's a pleasure for me now to introduce Billy Ingram. He is joining us all the way from US in Georgia. And he has a very interesting application of lean principles, also integrated with sustainability and very strong sustainability vision. So welcome, Billy. The floor is yours.
Thank you, Marina. Thank you for the opportunity. I'm going to share my screen right quick. So hang in there with me. All right, does that screen look good?
Still, we cannot see it.
Oh, I'm sorry. I have to click share.
It's coming, but I think we're, yes, now we see.
All right.
Thank you.
Yes, ma'am. Thank you. I'm glad it got up there. Well, thank you for the opportunity to share this case study. It's something that we've been working on for a while. Socially responsible Lean Six Sigma was something I had not considered in the past. And part of this is because I think I was living in a perception versus reality. But I'm going to go through this really quick. This is a part of my team at the bottom down here, and you can see we have fun while we are innovating. So one of the things I'd like to ask today of our attendees is, what is your definition of social responsibility? And this is important because to me, 6 or 8 years ago, I had a very different definition in my mind. So I would like for you to, in your mind, think about what that is. You don't have to write it down or anything, but just say, hey, this is what I think this is. So the principles of social responsibility are what I'm fixing to share with you very quickly. This is defined by the ISO 26000 guidelines. These principles start with accountability, transparency, ethical behavior, respect for stakeholder interests, respect for the rule of law, respect for international norms of behavior, respect for human rights. And this is part of our team. And these principles fit very well in here. And you see a part of our team standing in front of a mural of our founder, Ray Anderson. And he was big on sustainability. He actually led us into this in the mid-90s. So this fits very well with what we're doing, these principles do. And the reason it does is because these principles align with our organizational mission, as they do with most organizational missions, values, and people's individual personal beliefs. These principles, in my experience now, are what organizations should view innovation and improvement through. It's kind of like looking through a lens to see how we're going about it. The first subject of social responsibility, organizational governance, states that organizational decisions should be made in consideration of the expectations of society. And I'm just reading this off literally, the definition. Accountability, transparency, ethics, and stakeholders should be factors in the organization's decision-making process. Now, I was been involved with the last project with Myrna, which was not for Myrna, but last project I was involved with Myrna was the Gimbal Walk project, Dare to Gimbal. And for the same reason that Gimbal Walks are effective, applications of social responsibility and the understanding is effective too, because the thing they have in common is they both have to be applied in reality, not necessarily in someone's perception. So you have to be very careful about the reality of what you're doing. So it was just last week. This is a picture that, and I know it's a little small, but it's a picture from our new CEO, Laurel Hurd, who came by and visited us just this past week. And she's holding up a custom-made product we made for her to welcome her. But she faces many challenges, as well do all organizations and all CEOs nowadays. Attracting and retaining talent. Organizational cultures now are drawing or repelling people. And this is really important because there's a talent war brewing, or not brewing, I think it's boiling over now maybe. But there's generational differences. They're becoming more and more abundant. Clearly there's labor shortages. I'm not sure about globally, but in the US, there are significant labor shortages, especially in skilled laborers. This rapid and continuous market change, there's intensifying organizational expectations. Obviously, supply chain disruptions, cybersecurity issues are becoming more prevalent. And of course, digital transformation projects are all out there too. Great opportunities if we can actually take advantage of them. So one of the things that we've done in the past 5 years is we began setting very courageous expectations. And we enjoyed some benefits from this, which I'll share at the end. But these courageous expectations took the form of setting expectations for stakeholder interactions. So social responsibility principles are how we define the behavior we expect from stakeholders. They should be accountable. They should be transparent and ethical. They should respect each other. So just as an example, we enabled individual accountability and personal responsibility. And matter of fact, we made that new standard in our process. We enabled full individual engagement without resentment, because you can't have someone's full attention and their full effort if they're resentful. So, and to make sure that they're not resentful, we made sure that we increased the collaboration and setting of mutually beneficial goals. Our goals need to be good for the person and the organization. If you have goals that is good for the organization and not the person, you create resentment, and vice versa. You don't have people working on goals that are not good for the organization that they're trying to work for. So we enabled innovation through these actions and changing these behaviors. We enabled the aligned pursuit of organizational mission, and we enabled people to act on our organizational values and their personal beliefs and be aligned with them, with our mission. This is really important if you want people to do the work that the company is trying to get to. Also, by doing these things, we've increased our idea adoption and increased our reliability and productivity in the process. And again, this is something that was well outside of my ability and skill set in the past. But our journey looked something like this. And it started with awareness. And this was awareness for me personally. I became aware that many of my projects weren't implemented because of internal social resistance that I was ignorant of, just unaware of. So I began looking for a solution for my social gap. My ability to understand economics was good. I had Lean Six Sigma training, a lot of innovation training. So I could come up with good solutions, but and a lot of them were environmentally better from a sustainability standpoint. But socially, I was ill-equipped, let's just say it that way. But I found a great solution in a new emerging process, an evolution of Lean Six Sigma DMAIC called Scissor SOFARE. It's continual improvement for social responsibility. And I won't go into what SOFARE means, but basically it's like the socially responsible version of DMAIC. So I began to train and test myself. And as soon as I found out the ability to understand social issues was there, then I immediately began to encourage my team to learn this for themselves. But we did not require them to. We allowed for choice and let them volunteer. So as they began, interestingly enough, almost everyone chose to begin the training because they saw benefits it was giving me personally. So as we began to train together, and I went through the training, like I said, myself beforehand and tested it, but as we began to learn together, we began to learn how to speak a new language, a socially responsible language, and begin to act in that way. This led to predictable project success, especially in the scope of our function, which is product development and design. And of course, this led to purposeful cultural transformation. Especially, we noticed that when we interacted with people outside of our group, that we were positively impacting them in a good way. So we were improving their culture too. So then we kind of began to understand after we understood how to apply this method, we began to notice some other things. We began to notice myself and others around me. We began to believe we could make a difference with our mission. We could move our needle personally. Social investments and retention correlation was noticed. We were aggressively training our team and our volunteers, but no one was leaving. Everybody stayed, which is great. So we began to reduce our social resistance internally. And as we did, it enabled innovation, rapid innovation, not just with products, but also with process. We begin to build confidence through deliberate practice. We practice our projects. We run many projects a year, over and over and over, because we want people to be confident in their ability. We want them to think that they can make a difference in our culture and they can make a difference in our mission. And finally, we begin to act on our organizational values very much more confidently and begin to have team members say, I want to lead the next project because I want to demonstrate my skills. I want to help other people. So the benefits.
Sorry, Billy, you have 1 minute only.
Yes, ma'am. Last slide. We had a cultural transformation of 21% overall improvement. Individual engagement and personal responsibility are now the standard in our functional area. We have 2 master black belts, 12 scissor black belts also, but all within advanced innovation training. We have thriving innovation and adaptability in the absence of internal social resistance. Environmentally, we're creating carbon negative products now and better products. Economically, we've saved $1 million over the past 3 years after we paid for all the training, which was about $300,000 over 3 years. Product development has now set up a one-piece continuous flow, rapid prototyping environment where we use production equipment to both change, not just make better products, but to improve the process. So to leave you with a thought, my last 30 seconds, the physicist Amory Lovins, the co-founder and chairman emeritus of the Rocky Mountain Institute, said, the pace of innovation is not set by incumbents, but by insurgents. These insurgents are not inhibited by incumbents, business models, legacy assets, or culture. Therefore, in this spirit, leaders who govern in a socially responsible manner will define the future of work, and they will acquire the best people from those who do not. So please consider your social responsibility definition from the beginning, and I hope this presentation has changed your perception of how that can be used. Thank you, Marina.
Thank you, Billy. Thank you very much. So now the next presentation is for from Jaguar Land Rover. So Tesh, pleasure to introduce you. Tesh is an engineer in Jaguar Land Rover, working there already for more than 5 years. So welcome, the floor is yours.
Thank you, Minna. Let me just share my screen. All right, so is everyone able to see that?
Yes, thank you.
Okay, so good afternoon, everyone. I'm Tej, and I'll be presenting the Jaguar Land Rover Lean PD project that I undertook whilst I was at Cranfield University. So I'll be going through a quick introduction, a bit of a background to the project. I'll be going through the pilot project, the SBC pilot project we undertook, and just quickly talk through some of the benefits that we saw and presented after the project was done. So for myself, I've been working with the Jaguar Land Rover for just about 5 years now. I was a graduate engineer. Now I'm working as a test engineer in product engineering, and I undertook this project under Dr. Ahmed whilst I was studying, doing my master's at Cranfield University in product development and management. So yeah, and ended up at Jaguar Land Rover after. So just a bit of a background about why there was a requirement for collaboration between Jaguar Land Rover and Cranfield University. So back in 2016, 2017, Jaguar Land Rover was growing exponentially. The aim at that point was to try and sell 1 million cars per year by 2020. And in order to achieve that aim, there was a requirement for a lot of new products to be launched, which meant a lot of cars being engineered. Now, the company grew from about 4,000 engineers in 2008 to 2009 to 8,000 engineers in 2017. So that's a massive amount of intake. So there was a requirement to improve the product, to improve the processes, but also a requirement to get processes in place that would allow for better product development to happen, to maybe reuse some designs and SBC and then some of the components of SBC were very well suited to Jaguar Land Rover's needs at that point. So we undertook a project within the chassis department, which is one of the 10 functions within product development. And the idea was to demonstrate the SBC model via a pilot project. So taking an actual assembly and running the project through its life cycle, and try and showcase some of the benefits of SBC. So the assembly that we chose at that point was a brake pedal. We simplified or oversimplified, I should say, it into four parts at that point. And the ultimate goal was, as I said, to try and showcase that certain components of SBC could be really used to incorporate into the product development process at JLR, to try and improve the overall process itself. So obviously didn't have the time to incorporate everything. That would have taken a long involvement, but we had about 3 months to try and incorporate or do the project itself. And we took certain components and went from there. Now the most challenging, very challenging bit was to try and capture the key value attributes to look at, if we were trying to develop a brake pedal, what are the key value attributes, what are the main components that we're looking at to try and improve on or try and base your design around. So did a lot of brainstorming with the engineers over here at JLR. We did a lot of interviews, looked at the current product at that time, came up with some definitions and narrowed it down to the value attributes. So we looked at where we could do within the 4 components we could do the actual implementation. So we chose the bracket with a high level of innovation possibility, and we chose the pedal arm with a medium level of innovation possibility. Now, there were designs made with the help of the engineers there and our own work, where we looked at designing the components based off stiffness, durability, safety, cost reduction, which were the key value attributes. And we looked at 3 different materials that we could design those components with. So that in total gave us 4 designs and 3 different materials, which gave us 12 solutions altogether for the bracket. And we repeated the same process for the pedal arm, and which gave us another 12 designs. So in total, we ended up with a combination of 144 designs. Now, obviously 144 designs is a lot. You can't rapid prototype 144 designs. So you have to aggressively sort of come up with a fewer designs or choose some of the designs. Now, how do we do that now? So we looked at simulation. We looked at the value attributes, so cost versus weight, stress, factor of safety, and we ran CAE modeling through those and came up with the graph essentially. So you've got, for example, design B1 with aluminum, or you've got B2 with glass-filled nylon, and we ran them through the we ran them through the boundary conditions that we had acquired. Oops, something's happening. Right. Sorry. My laptop seems to be playing up. Right, where was I? So yeah, we ran them through looked at the trade-off curves, looked at the boundary conditions. So what is the cost of the material, weight of the material, and everything that then set within that or sat within the boundary constraints we chose, and discarded the rest. So we came up with 6 combinations, and we put those 6 combinations through the same process and then further reduced it to three different alternatives and looked at implementing a Pew matrix, and ultimately came up with one single solution, which we then suggested. Now, in terms of the benefits that we presented based off the process we'd ran through, we increased the number of designs that we'd generated. We'd improved the bracket stiffness. We'd improve the pedal arm stiffness, reduce the weight, reduce the material cost, increase the reliability, and reduce the overall risk of failing in terms of the whole process. And this actually led into further study that we did with Jaguar Land Rover at that point, where we looked into a lot of reusing of ideas and coming up with a very new topic at that point of knowledge shelf that we looked at implementing as well. We looked at implementing trade-off curves, and I want to say that we've that was 5 years ago, and we have now implemented a lot of those learnings into our new product development system, and we are seeing the benefit from it. So yeah, thank you for giving me the opportunity to present.
Thank you, Tesh. That
Give it
was
back
very,
to
very
Mirna.
interesting. Yes, thank you. Just to validate the numbers, you said that how many years did you grow up your engineering team? Did I hear right, from 400 to 8,000? Can you repeat those numbers? That was interesting.
So we went 4,000 and about 2010 to 8,000 people in 2016, 2017 when we were doing the project. That is just within the engineering team, but the company grew massively, and obviously we had loads of other challenges that I assume every company has when you're growing that quickly.
Amazing. Thank you. Thank you very much, Tesh.
Yep.
So we do have some questions. There was one for you, Ahmed, I think. This is from Fernando. How much time did it take to Rolls-Royce to use set-based concurrent engineering? How was the process to get this method running on conceptual design? Ahmed, you are on mute.
Yeah, I answered that, but we did it in different stages. So it was like first 3 months, then 4 months, then 2 years, then 1 year. And all of it because they have so many different stages, and different stages, they have different set of activity and different purpose. And then throughout that period, we were working from them from 2009 until basically January, February 2016. So throughout all of that, we were working different research and development in actual projects. So as we are doing the work, there's different element, they use it throughout the work. So in general, we as academic, when we work with them, we have to work within research and development. We do not work with the research, the commercial part of it. That's the job of the company. In this case, like John Parson, like what Tej just presented, Jaguar Land Rover, they were using quite a lot of stuff individually. I was invited in several design review on how their chief engineer asked them to apply the principle on the learning of the project in their daily activities. So that is the way we do it. Thank you.
So just I'm going to complement. So imagine a company calls you and they tell you, I want to do that base. I love the case from Jaguar Land Rover, Atlas Copco, Rolls-Royce. So in very simple words, how would you propose a project as you presented? Assessment,
let us make the case of Atlas Copco. I mean, just what Ben presented. So what happened? That is their innovation manager. He started the study at the Cranfield, and he took the classes with me about lean product development, which is the same classes that Tej take when he was a student. Then he called his attention, and here were the kickoff of discussion. So it was an opportunity, a very short project of 4 months, and they selected the case study. And we gave them a bit of a seminar, about 1 hour and a half, 2 hours. And then they select the case study that's presented by Ben, and then we work. And the way that Glenn did, he just left them actually to decide to work with us in order to evaluate the value of it. But the result was better than expected, and come up with a solution. Again, this solution I wouldn't call commercial. They have to take it, like Ben and one of his team, take it further and do the further engineering and convert it into the commercial. So because of the good result that we did with them, we carry on the work now. We're just finishing, which is converting the whole product development into a lean environment, as well as using digital twin for the compact bulk feeder, which is some of the photos that Ben shared. Actually, one colleague of Ben, Mike, he went to another company. He approached me to apply set-based concrete engineering in their tooling and so on. So this is how it works, basically. Thank you.
Okay, thank you, Ahmed. There's a question about engineering attributes. So how do you get engineering attributes?
I did not understand the question. So if he explains to us what he means, then maybe we'll
I think that's rooted towards well, when I was talking about key value attributes in my presentation. Now, in terms of the project itself, because the scope was not company-wide, we ended up looking at the current product itself, so the current pedal arms and bracketry, and having long conversations and brainstorming sessions with the engineers responsible for making that part. But in general, when you look at engineering attributes, you will, for a company like Jaguar Land Rover, you look at the brands themselves. So you've got two big brands. One is Jaguar, one is Land Rover. Now they will have their separate DNAs. So for example, Land Rover is a quintessential luxury SUV, which is marketed to be doing anything and everything, so going above and beyond, whereas Jaguar is a sports sedan or a sports car, a lot more sportier, something you'll enjoy driving. So you look at that, you might have brainstorming, or not brainstorming sessions, but you might have feedback from the actual customers themselves during the original concept stage, but you also get a lot of those requirements from the marketing team, which do a lot of research with the customers, with the competition, to see what are they doing, how can we make it slightly better. So that's where you get those attributes from. So you don't get told that, yes, we need the tensile strength of, or we need the stiffness to be X. You get told that I want a sports car, and then that gets translated to engineering terms, what will make a sports car, and you go from there.
Thank you, Tej. Just one comment for everybody that is attending. The interesting, I think, good thing of these awards is that we are documenting all these cases. So each and every case from every finalist has a detailed document around, depends on the case, even one is 50 pages. We have, I think, average 30 pages explaining all the journey, everything that was done. So that will be also published and available in the awards ceremony. So just before we conclude the session, well, first of all, thank you to all the gentlemen and finalists. We were just talking before when we started the presentation. This is really acknowledging your efforts of all those years of hard work. And for participants, as I was saying, we'll have the award ceremony on the 8th of June. This is the link. It was pasted on the chat. You can join online or in presence in Brussels. It's free of charge. And the same day, we will be publishing the cases that explain in detail what these finalists have done during the past years. So having said that, the next Cappuccino Talk will be on Lean Digital. So we have two cases on Lean Digital. One is a Norwegian company, and the other one a Japanese company based in Europe. So we will be having that as our third group of Lean Digital finalists, and then prepare for our awards on the 8th of June. So a big applause for the gentleman.